Hello everyone, welcome to the channel IGCSE and GCSE Maths School. Today we are going to do an examination question. That is the question number 19 of 1H paper of Mathematics A specification of Edexcel IGCSE January 2023. Question 19 of 1H paper of Mathematics specification A of Edexcel IGCSE January 2023. Right, that is the question. This is relating to upper bound and lower bound, the topic that we are discussing these days. And there's some specialty in this question. That is here the question here, value of A. Work out the value of A to a suitable degree of accuracy. Then they ask the suitable degree of accuracy. They haven't given us a specific degree of accuracy as correct to 2 significant figures, correct to 2 decimal places, correct 3 significant figures, correct to 1 decimal place, so 1 significant figure. So like that, they haven't given a specific degree of accuracy. What they give is suitable degree of accuracy, that we have to determine the suitable degree of accuracy within the given criteria by them. Okay, we'll see how we can do that. Right, okay. We have to decide the degree of accuracy here. They don't give. Okay. And that degree of accuracy must be suitable. Now go to this. Therefore, we can't choose whatever degree of accuracy as 3 correct to 3 significant figures, 2 significant figures, 3 decimal places, 2 decimal places, as we wish. We can't do. Because our degree of accuracy that we choose must be suitable. Suitable degree of accuracy. They have used the word suitable here. Okay. Okay, we will see how that suitable degree of accuracy is chosen. Right, okay. Go to next. The question 19. We read the question, if A equals V minus U over T, where V equals 45.23 to 2 decimal places, U equals 5.12 to 2 decimal places, T equals 8.5 to 2 significant figures. Then by considering bounds, here, this is the words bounds. What are bounds? What do you mean bounds? Bounds here? Bounds back. Bounds. Bounds means upper bound and lower bound, UB and LB. That is what's meant by the word bounds there. Right, okay. Then by considering the bounds, work out the value of A to suitable degree of accuracy. Right, okay. They ask you to consider the bounds of then that means we have to find the upper bound of A and lower bound of A and consider those bounds and choose the suitable degree of accuracy. Okay. Then we will do, right? Then we will calculate first of all upper bound. Upper bound of A. A equals, how do you find the upper bound of the upper bound of this? This is a division. So the division of two numbers. Then upper bound of division means upper bound of quotient. What is the rule relating to the upper bound of quotient? How to get the upper bound of quotient? Upper bound of quotient equals upper bound of the dividend divided by lower bound of the divisor. This is the dividend. Sorry, we'll write first of all the question here. A equals V minus U over T. Read the question. This whole thing is the dividend. Dividend. This one is called divisor. Okay. Now see. Then what is the? Then we are going to find the upper bound of A. Upper bound. This actually the division. Then answer that you divide one number by another one is called quotient. Therefore, A must is the answer after dividing this by T. Answer after dividing V minus U by T, then A must be the quotient of this division. Then we have to use the principles of upper bound and lower bound of a quotient. How did we find the upper bound and lower bound of a quotient? Upper bound or lower bound, upper bound of a quotient equals upper bound of the dividend, that is top value, divided by the lower bound of the divisor. Upper bound of the dividend divided by the lower bound of the divisor. That is how you find the upper bound of quotient. Alright, then we will find the upper bound of A. Then upper bound of then A equals upper bound of V minus U divided by upper bound of divided by lower bound of t. Then write a equals upper bound of what? V minus u. Then divided by lower bound of what? The divisor t. Okay. Now we have to find the upper bound of v minus u and lower bound of t. Okay. Then the lower bound. This is upper bound, right? This is the upper bound of a. Then we will find the formula for lower bound of a. Lower bound of a. How do you find the lower bound of a? How do you find the lower bound? Lower bound of quotient, this is the quotient, that is the answer after dividing v minus u by t. Therefore, this answer of a division is called quotient. How do you find the lower bound of a quotient? What is the formula for finding the lower bound of a quotient? Lower bound of a quotient equals lower bound of the dividend divided by the upper bound of the divisor. Lower bound of the dividend divided by the upper bound of the divisor. That is how to find the lower bound of quotient. The lower bound of quotient equals lower bound of quotient, lower bound of a equals the lower bound of this dividend. Right, lower bound of what? This dividend. What is the dividend here? V minus u. Then divided by upper bound of what? What is that called? T. Upper bound of t. Right. Okay, now we need lower bound of v minus u, lower bound of t, upper bound of t, lower bound of v minus t. Right. Okay, now we will find it as working side. Now, what is that? V minus u. Right. Now you have the upper bound. Upper bound of v minus what? U. Upper bound of v minus u. Then this is what? This is a difference of two terms. We learn how to find the difference of how to find the upper bound of difference of two terms. How do you find the upper? What is the formula that we introduced that we learn to find the upper bound of difference of two terms? Upper bound difference. Upper bound of difference of two terms is equal to upper bound of the larger value minus lower bound of the smaller value. Then you write upper bound of this v minus lower bound of what? This u. That is how we find the upper bound of v minus u. Upper bound of difference equals upper bound of larger value minus lower bound of smaller value. Now we calculate. Then we will get this upper bound of v. How do you find the upper bound of v? This one. Corrected value. This upper bound of a single corrected value. Then the general formula for finding the upper bound of single corrected value is corrected value plus degree of accuracy over 2. Corrected value plus degree of accuracy over 2. Then this one, corrected value of v plus degree of accuracy over 2. What is the corrected value of v? That is 45. 45.23. 45.23. That is the corrected value. And plus degree of accuracy over t. What is the degree of accuracy? What is the degree of accuracy of this? To 2 decimal places. That is correct to 2 decimal places. That's the correct to second decimal place. We learned that when the number has been written correct to 2 decimal places, the degree of accuracy is the 0.01. 0.01. That is the degree of accuracy to be used for finding the upper bound and lower bound in those formulae when a number has been corrected to 2 decimal places. What is the degree of accuracy? 0.01. Then right here we have learned that. Go to those learning videos and see. They play then 0.01 over 2. Right. Okay. Then that is the upper bound of this. Then lower bound of u. How do you find the lower bound of u? Minus lower bound of u. Lower bound of u. Lower bound of u is the lower bound of single corrected value. Therefore, the formula is lower bound equals corrected value minus degree of accuracy over 2. Corrected value minus degree of accuracy over 2. Then here u, corrected value of u will take corrected value of 5.12. Then corrected value of u is that. And then the correct it has been written correct to 2 decimal places. Again, the degree of accuracy is the second decimal. What is the degree of accuracy? That is the second decimal. That is degree of accuracy second decimal means that is 0.01. 0.01. So 0.01 is the degree of accuracy that should be used in the formula to find the upper bound and lower bound when the number is corrected to 2 decimal places. Therefore, corrected value is 0.01 divided by 2. Okay. Then we write this one. Then 45 plus 2.3, then it will be 45.235. This one will be how much? This one will be 45.235. This one will be how much? You have to deduct 0.05 from 5.12, then you will get 5.115. That is the lower bound. Okay, 5.115. Then you deduct those two. Then you are getting how much? You deduct this 5 from this one, 0. You deduct this 1 from this one. You get here 2. You get here or 1. You get here 5. Then it's 40. Then this is 40.12. That is how much? 40.12. 40.12. 40.12 is the upper bound of V minus U. Okay. Right. Okay. Then we are going to lower bound of V minus U. Okay. Lower bound of V minus U. Then how to find the lower bound of difference? This another lower bound of V minus U means lower bound of difference of two terms. How to find the lower bound of difference? Lower bound of difference equals lower bound of the larger value minus upper bound of the smaller value. Lower bound of larger value, L, lower bound of V, then lower bound of V minus upper bound of U, smaller value, upper bound of what? U, that is smaller value, right? So that is the way of finding the lower bound of a difference of two terms, right? Now we will see. Then first one, the lower bound of V. Lower bound of V means lower bound of a single corrected value. The formula is corrected value minus degree of accuracy over 2. Then corrected value of V is how much? It is given here 45.23 minus degree of accuracy over 2. What is the degree of accuracy in the correct two decimal place? 0.01, then divided by 2. Then minus, then upper bound of U means upper bound of single corrected value. The relevant formula is upper bound equals corrected value plus degree of accuracy over 2. Then go to the corrected value of U, that is 5.12. Then plus degree of accuracy over what are the degree of accuracy? Also correct two decimal places. Therefore, the degree of accuracy to be used in finding the lower bound, upper bound is by using the formula is 0.01. Then write 0.01. Then that is divided by 2. Right. Okay. Then you calculate this. Then you work out this here. 45 plus 23 minus, that means 45.225. This one. Then minus this one is how much? 512 0.001. That means 5.125. Right. So that is the answer. Right. Okay. Then you subtract this also and get the answer. How much? You are getting how much? You are getting 5502201. No, 40.1. Okay, 40.1. Okay, that is the lower bound of V minus U. Now we have to find the upper bound of T and upper bound of T. Upper bound of T. Look at upper bound of T. Upper bound of T is upper bound of single corrected value. The general formula can be applied. That is upper bound equals corrected value plus degree of accuracy over 2. Then go to the corrected value of T. That is 8.5. 8.5 plus degree of accuracy is two significant figures. Two significant figures means first significant, but second significant. This is the second significant. We go to the place value of that. That is first decimal. First decimal. Otherwise, first decimal. When the first decimal is the corrected value, degree of accuracy to be used here is in the formula of upper bound is 0.1 divided by 2. Okay. How much? Then it will be 8.55. 8.55. That is the upper bound of T. Then it is the lower bound of T. Lower bound of T. What is lower bound of T? So lower bound of T, what is the point of single corrected values? So therefore, general formula for find the lower bound can be applied as a corrected value minus degree of accuracy over 2. Then what is the corrected value of T? That is 8.5 minus degree of accuracy of 2. That is same as this. The previous one when upper bound of T was found, that was T. Second significant figure is this. Then its place value should be taken, but the place value is first decimal. When the degree of accuracy is first decimal, what is the degree of accuracy? 0.1, 0.1, 0.1, 0.1 divided by 2. Then what are you getting? 8.45, 8.45. See, that is the lower bound of T. Right. Now you use this in this formula. Then upper bound of A. Now we can substitute. Upper bound of A is what? Upper bound of V minus U. Upper bound of V are 40.12. 40.12. Okay. Divided by what? It will be lower bound of what? T. What is the lower bound of T? 8.45. 8.45. Then other one, this one. Then lower bound of A. Lower bound of A is lower bound of V minus U. What is the lower bound of V minus U? 40.1. 40.1. What is the then upper bound of T? What is the upper bound of T? That 8.55. Right. We will calculate by using the calculator here. What is that? 40.12. 40.12. Then divided by 8.45. 8.45. 40.12, yes. Then the answer will be 4.74 something something. 4. This one equals 4.74. 4.74 7928. 7928. We will write several decimal places like this because later on we have to again round it to a suitable degree of accuracy, right? Then next one, we will calculate the lower bound of A also. That is 40.1 divided by 8.4455. How much? That is 4.692. That is 4.692. 4.69005, sir. 69005. Okay, that is enough. Okay. Now we will look at. Now we are going to give the answer. Give the answer of A, value of A, to a suitable degree of accuracy. The suitable degree of accuracy means that should be a degree of accuracy. From which the answer that comes must be same for upper bound and lower bound both. That is the thing. Then if it is a suitable degree of accuracy, with that degree of accuracy, the answer that comes must be the same for the upper bound and lower bound. So that is the that is how you choose the suitable degree of accuracy. You have to give the answer correct to a suitable degree of accuracy, which gives the same value for upper bound and lower bound. Okay. Now here, now take this 4, then write this correct to 1 decimal, what you call one nearest unit, otherwise correct to 1 significant figure. Then this is the first significant figure. This is greater than 5. Add on to this one, that it will be 5. Here also correct to nearest what you call correct one significant figure, it is here, this one is the first significant figure, then this one greater than 5, add 1, then you get 5, 5. Put zeros for this, then you are getting the same answer. But that is not the most accurate answer. When you give the answer to the for A, suitable degree of accuracy, it must be the answer which is most accurate. This is not most accurate, this one. By just writing why? Because this value has so many decimal places. This value also has so many decimal places. So therefore, this 4, because this answer differs by considerable margin when you take these decimal places. Therefore, when to pose the accuracy to be most, the suitable degree of accuracy must be degree of accuracy which is chosen with the highest possible number of significant figures or decimal places. Highest possible number of significant figures or decimal places. Then now we will go to the highest. We will go to this third one here 0. Here 7. But when you write this correct to 4 significant figures, this will be 8. Here is there no. Here anywhere, here also is not so. Then here is not so. Here not so. When they take this one, this 2 and 2, this one is 5, this one is 7. Sorry, this one is 9. If you take write this correct to 3 significant figures, this is the third significant figure, this is the third significant figure, then this one if written correct to 3 significant figures, it will be 4.75 because this is the third significant figure, this significant figure is less than 5, add 1 to this one, that is 4.75. This one, if this one is written correct to 3 significant figures, then 4 points is third significant figure is 9. Then here there is no value, that is 0. Therefore, this is the value after writing this correct to 3 significant figure, that is 4.69. This is 4.75. That is also no, we are not getting same answer. Right? Here we get 4.75, we get 4.69. They are wrong. Therefore, then we will come to this one. We will come to this one. We will write this correct to 2 significant figures. If we write correct 2 significant figures, this one, here is the second significant figure. This is less than pi, no addition. Therefore, 4.7 will be the answer if it is written correct 2 significant figures. Come to this one. Write this correct to 2 significant figures. That is second significant figure is the 6. This is the first one. This is the second significant figure. Then fourth significant figure. This one is greater than 5. Add 1 to them. That is 4.7. Right. So that is this one. And second significant figure. If you correct the 2 bounds to second significant figure, then you are getting the same answer for both upper bound and lower bound, and the answer will have the most number of highest number of decimal places, highest number of digits, highest number of significant figures, or highest number of decimal places, highest number of digits. And therefore suitable degree of accuracy will be correct to 2 significant figures. Right? Okay. Therefore, if this is written correct to 2 significant figures, that is equal to how much? 4.7 correct to 2SF. This one also correct 2 significant figure. It is equal to what? 4 approximately equal 4.7. That is to 2SF. So therefore, answer is 4.7. That is the most accurate answer. That is most accurate answer possible. That's the most accurate answer possible with the highest number of significant figures possible. See, so that is the answer. Therefore, A equals how much? 4.7. Okay, right. So that is the answer for this. And just watch this video. And if you have any problems, comment in the comment section. So I will further make explanations if you have any further problems. Okay, thank you. Have a nice time. See you. Okay, bye.